we are telling about binding energy of this. Binding energy is nothing but there is a mass loss. Or sometimes they are telling it is a mass defect. So this is more mass defect, more energy. So if we convert into this mass loss, it will be nothing but 931 millivolt. This is the nuclear energy. This is the where you are converting mass into energy. Now you got the point?
Yes.
Because practically we never see mass is converted to energy. Only nuclear phenomena is there where you can see mass is converted to energy and vice versa also. Those who know the positron, they understand. Positron is converted to energy. To energy. Those who know physics, they understand it well. Or later I can say. So the mass defect that is actually an immense source of. What are nuclear? This one factor nuclear energy is there. That is conventional development. Huge amount of energy. That is actually utilizing nuclear reaction. Got it? So far so good. Now we have understood isotope, we have understood mass. Now we come to the nuclear reaction. There are two types of nuclear reaction. There are two types. Either it can break, either you can break the nucleus or you can combine them. So breaking of nucleus is called as fission, and combining of the nucleus is called as fusion. So only two reactions, nothing else. Okay. So fusion, how it is happening, let us see. See, this is the fusion. Now I am telling you how fusion is. This is called a thermonuclear reaction. Actually, I misunderstood. See, the major source of energy on the earth is sun. You know, sun पे भी कहाँ से आती है energy? It is a nuclear reaction. The nuclear reaction that is nothing but called as nuclear fusion reaction. See, small amount of helium they combine together for this one and the proton will release huge amount. So, I'll come to the nuclear reaction. This is the sun reaction which is taking place. What is there? Nothing but you combine with the hydrogen, then they will combine with deuterium, and then deuterium hydrogen for helium, 3, and then 2 helium will combine with the 4, and then again proton will be added. And cycling goes on goes on. And huge amount, the energy part you know, how hot sun is. But the question is, if it is so, why we cannot do another? The problem is because to happen this reaction, we require huge amount of energy. See, you can penetrate something like electron cloud, but to fuse something against the nuclear barrier, it is like highly impossible. So to conduct this kind of reaction, which is nothing but ITER, आपने नाम सुना है किसी ने? वर्ल्ड में न्यूक्लियर फ्यूजन रिएक्टर्स का काम हो रहा है, ITER इसका नाम, इंटरनेशनल. There actually this nuclear phenomena is being studied, researched, huge number of research. And future is not far away, maybe after 100 years or maybe 50 years, you will get a nuclear explosion here. But only problem is that because combining to nuclei itself against the barrier, because this is also positive, this is also positive. See, both nucleus are positive. And you are combining to positive things. So you require a temperature which is something like the order of sun temperature. 300 to 5, 300 to 6 degree temperature. That is why wherever fusion reaction is taking place, it is always fission first done. But fission is done so that you increase the temperature, you get the temperature, then you combine the two. Okay. So now I think it's okay or any further question? Because fusion is not possible at normal temperature. You cannot because you require very high temperature. And that is why it's got sometimes a thermonuclear reaction. And there is something called a thermonuclear energy. Okay, we will not waste the time. I hope you are getting something on. Tell me I am speaking something. It's okay?
Yes, yes.
So, now coming back to nuclear fission, as you know, you just break something for the nuclear fission. Now there is a trick. Fission is nothing but division of anti-nucleus into nucleus, right? That's okay. You just bombard the neutron and it will break down into the fission. Now the question comes here: that any atom can undergo fission. Why especially? Why it is so? I just explain how it happens. See, you may be knowing the chemical reaction, right? So chemical reaction क्या होता है, like if you react for A plus B, it will go and cross the barrier which is called as transient activation. For example, it may be written. You require activation energy to cross. See, any reaction cannot react. Unless until you cross this barrier, you cannot have. So just increase the activation, just cross the activation energy barrier. What or laboratory? Any idea? Suppose two things are not actually not adequate. How will you do it? What will we are doing, right? We are doing temperature. We are just heating. What essentially we are doing? Actually, this is at lower energy level. We are increasing it. So that it can easily jump over and cross the barrier and get temperature. So that's called a heating. But other reaction also there. What is called a, we are sometimes using catalyst. You know catalyst?
Rate of reaction will increase.
You know, any chemical reaction there is some catalyst coming in the right?
Yes, to increase the rate.
What is the role of catalyst?
To increase the rate of reaction.
Fast. How it does it? Basically.
Ya, primer energía mía cuando va a la guest house.
So that it is easily crossed. Even after heating it is a positive. So what can you calculate that? Or obviously to cross this
सब लोग
typically nuclear reaction.
देसी
You
सब
see
लोग
the
करो
nuclear reaction in the process of chemical reaction, you understand it.
इधर सब लोग
For example,
सब लोग क्यों खाए एमएससी बीएससी सब सब पर हाँ बीएससी भी
if you provide something like neutron, it will form something is missing. I don't know. So you will form a compound. This compound nucleus has to cross some barrier. Unless until it cross the barrier, it will not enter. Right? That barrier is called a fission barrier. So this fission barrier is nothing but it is activation barrier. Okay, in nuclear phenomena we call it fission barrier, in chemical reaction we call it activation barrier. So unless until you cross the fission barrier, for example, how it happens those who are from nuclear side, say if we combine neutron, it will start oscillation. Unless until it cross fission barrier, it will not split. Otherwise, again it will combine and transform. So what is important is your fission barrier. Now you will be understanding whether any element can undergo fission. I will say no. Those who have only those elements, we have only low fission barrier they can have. If suppose the fission barrier is very large, I cannot jump here, right? So if it is small, I can jump. So there are some nuclei which have very small fission barrier. They undergo fission. They are called a fissile metal. Fissile metal is सबको पता है ना? All metals are not fissile, but some of the elements they have very low fission barrier. For example, naturally there is only one natural. Uranium-235 is the only naturally occurring fissile metal. Other elements like plutonium, uranium-233, they are man-made elements. Got it? But there are certain materials, they are called as fertile materials. Now I am coming to the PFBR or 5 meter reactor, proton 5 meter reactor. See, we have thorium. Thorium-232, like a world largest product. India is like largest reservoir of thorium, right? So what is the use of thorium? Thorium is called a fertile material. The fertile material means the material which can be, they are not actually fissile material, but they can be converted into fertile material. So they are called as fertile material. So fertile material they can be converted into fissile material. For example, uranium-238 is a fertile that can be converted to uranium-239. Similarly, thorium-232 it can be converted to uranium-233. So both are important. So that is why thorium, why important of thorium is you can convert thorium into uranium-233, which is again fissile. So in part reactor it is like this only. You combine something, you start the reactor and you put a blanket of thorium. So in situ it will be generating your fission, fissile. That means the fuel you are consuming is producing more fuel than it is consuming. That is why it is called a breeder reactor. It is breeding actually. See, if you have some device, you have in a nuclear reactor, why you have some fissile, you get a fission. it will, then at the moment it will come, all fission materials are consumed. Now you have to remove the fuel rod. But if you combine with something like Surya or uranium 238, what will happen? It will instantly produce. So the moment you are consuming something, but you are producing double of that what you are consuming. So that is why it is called as breeder. It is breeding. But it is not so simple technology. See, theoretically it is very simple. But you have to convert it to technology part. That is called as R&D or something like that. Okay, now you got it, na? Sir, please.
ये इन्वेस्टमेंट जो है वो फर्टाइल टू फिशाइल में कन्वर्ट कैसे करते हैं?
For example, जो हमारा यूरेनियम 230 नेचुरल यूरेनियम है,
तो एनरिचमेंट ऑफ जो
and 99.3% आपका यूरेनियम 238 है.
तो यानी कि फर्टाइल से
Fertile only 0.7%. That is actually used in an area. Suppose you are using 1 ton of uranium fuel bundle, which is natural. So you will be getting only 7 kg of uranium. That means I can use the bundle only 7%, only 7 kg. I have to use 1 ton. But enrichment means I will increase the concentration of uranium
पानी है वो
beyond the natural. You are getting answer? Enrichment means your fissile content you are increasing. Naturally 0.7%. You want to make it 20%, 30%, 50%. So you have to increase the concentration of uranium 35 against uranium 31. There are several methods. Like the gas diffusion method, so many methods are there. You may be much better. But this is again there is a vast area how enrichment is. You get it? So what is the purpose of enrichment? Purpose of enrichment is in small amount you can have better energy, more energy. See, suppose I want to use 1 kg of uranium, 1.7 kg of uranium, I have to use 1 ton. Because it is natural. But enrichment if you can do, it can be do 0.7 kg only, this much amount you can use, same amount of energy. That is called enrichment. And enrichment is also done for other purpose, like military purpose. The reason is because what happens, see how it is happening. If you are diverting the mind, okay, no problem. See, in nuclear reaction, okay, I'll come to that. You will come to understand like how enrichment is important. This is a reaction like how uranium is converted to plutonium. The nuclear reaction, nuclear reactors, why they are important? Important because they are whatever they are consuming this one. But we are producing more of nuclear fuel. That is why they are more important. That is again it is a fissile. So whatever waste we are getting, that is the burnt fuel. Whatever ash we are getting from nuclear reactor, that is more precious than what is that been used there. And that is very important. It is not thrown. It is always used, recycled, combined and all. So how you are producing? You are using this natural and it will be converted into this. Similarly, if you are using Surya, it will be converted into this. See, practically, even iron rod can be converted into gold. Theoretically, you can calculate, like you go on buying neutron. But the cost of production will be such high, it is not like it will not be feasible. So that is why practically it is difficult, but theoretically you can do anything, convert anything in it. If you have reactors, because why nuclear reactors are important? Because they are the producer of neutrons and it will be required. So coming to the changes, there are two important things. Very, very important area. See, this is reaction to know. Even at 12th standard chemistry physics book, it is there. Uranium 235 to bombard a neutron, it will be converted to so and so element, and it will be producing 3 neutrons. How much? 3 neutrons. Just imagine something. You start something like uranium 235, and you require only 1 neutron, but you are producing 3 neutrons. So it will again tell you fission. So if you don't control the number of neutrons, what will happen? It will be chain reaction will be uncontrolled chain.
ये चलो
It will lead to your
तो कब बोले ना सब करी ना
That is the
कहाँ रखे हैं
Okay. Now the question is why is it important? Because each radioactive element has a property. They also actually emit good property. So But number of neutrons supposed to have natural, the number of neutrons are so less, they will not start self-changing. But if you combine more, it will start self-changing. If you have more enrichment product, like for example, you may know Iran is enriching something like that, 50%, 60%. But rate-of-rate element is even more than 97%. Because unless it is that enrichment you reach, if you store somewhere, it will start immediately. It will be emitting first, then it will start changing. Otherwise, you have to initiate changes. For example, in the nuclear reactors, we have to initiate changes. If you are not controlling what will happen, it will lead to explosion. And other phenomena is what? You control them apart from. You are getting or not? You are producing 3 neutrons, you kill 2 neutrons. I will control your neutrons. You just remove those 2 neutrons. It will be called as control change, and that is the phenomenon of nuclear reactor. So getting it or not? An important point is, when nuclear reactor is a device, nothing but a tool है, आपने समझ लो एक box है, you are controlling number of neutrons, nothing. बहुत simple. Of course, technologically थोड़ा challenge. Another important thing is, now I will not discuss. I will go to the health side. वो दूसरा वाला हम बनाए नहीं क्या हमारा पावर पॉइंट?
दूसरा वाला कौन सा?
एक और है हेल्थ केयर नहीं है?
एक और है ना, एक पीपीटी और है।
Okay, we will be here. Sorry. One more phenomenon. You may be knowing that is something called as thermal neutron. Thermal neutron is energy wise, 0.025 eV is called as thermal neutron. But in the nuclear reactors, the number of neutrons they generate is fast neutrons, very fast. They can cross any direction, but they are not useful. They are not in the nuclear reactor. Nuclear reactors, you have to control the number as well as the energy of the nucleus. If they are more energetic, what will happen? It will cross the nucleus. It will not do the nucleation. You have to combine with the nucleus. So you have to reduce the energy, that is called as thermalization of energy. Thermalization, what is not temperature, please. It is KT. Temperature at room temperature plus K is nothing but original constant. KT. So thermalization means reducing the energy, not the temperature. So हम लोग बात सुनते हैं यार, thermalize neutron. It is not related to temperature, it is related to energy. Thermal neutron means the energy which is something like 0.02 eV, electron volt energy is called as thermal. So this is the most suitable neutron to do the reaction. But what we are getting is fast neutron. They are not useful. So what we have to do, we have to thermalize them, we have to control them. They are excited, we have to control them. That is called as that is done by moderator. That is called as moderator. How moderator is that? See. Sorry. Oh, this is a control rod. So means that see there are some neutron absorbers. वो जो है extra neutron को absorb करेंगे and one neutron को छोड़ेंगे. That is called a control. That is called as thermalization. Moderator. See how we can think of moderator or reducing the energy of two elements like some moving particle. Physics people they should actually give the answer. Suppose there is a moving particle. I want to reduce the energy. So how is that? You have to collide with something, right? Because neutrons are zero energy charge, zero charge energy. They can penetrate anywhere. They cannot be deviated by electric field or something. They are zero charge, right? So there is very difficult to stop the neutron. What is the only thing is there? You have to collide with it. And if you know the basic of your physics, then energy transfer is maximum when the two particles are equal. You know, this is some okay? So any energy, two particles, same energy, if they are same size, if they combine, it will give more energy transfer. More energy transfer means, suppose I start with 100% energy, in one collision line it will be 50%, right? So which is the most suitable neutron moderator? Sorry? आप पता नहीं रख सकते कैल्शियम रहता है मैग्नीशियम रहता है smallest unit atom. Smallest atom is nothing but hydrogen. Because hydrogen size and neutron size are not equal. So hydrogen is the best this moderator for because size. So you see, if you just give me an example, if you are using water as a moderator, then 3 to 4 collisions, fast neutron, it will reduce to 0.02. You just convert it into hydrogen, you just convert it to deuterium. You know heavy water, nothing but heavy water is nothing but T2. What is D2 is nothing but hydrogen, isotope of hydrogen. It is deuterium. Just one neutron you are adding. The size becomes so large, now the moderation will take place in 27. If you are taking water, your moderation will be only 3 to 4 times collisions, it will reduce to this level. You just convert to deuterium, it will take 25, 26 collisions. So see huge difference. That is why purposely some reactors they are using more natural water or water as a moderator, and some reactors they are using heavy water reactor. It's the reason. Reason is because of weight design. See, where we are using heavy water, we are using water because it will be more enrichment. More enrichment if you are using, the number of neutrons will not be problem because your enrichment or number of will be more, so it can collide to anywhere. But suppose you are using natural uranium, like uranium 238, where you have only 0.7% of fissile content. So there you require more neutronic power. That is why you are using deuterium. So now one more reaction of the girl will come because I'm sorry I'm not able to open my slide. See, one more question. See, you want to continue the sustained change, right? So what is the condition? The condition will be you are producing the neutron and also you are consuming it, right? So this ratio is nothing but called as K factor. So number of neutrons produced per fission and number of neutrons consumed per fission. That is called as K factor. Suppose just imagine, if your K factor is more than 1, what will happen? Your neutrons, the number of neutrons will increase, it will undergo like violent reaction, it will lead to explosion. Similarly, if you have K factor less than 1, these neutrons are more consumed. What will happen? Neutrons will not be there to do the reaction, your nuclear reaction will stop. So perfectly you need to make K equal to perfectly 1. So this is how it is actually controlled. So if you can control K 1, you can continuously run your reaction. This is how it is run. Suppose you want to increase energy, you increase the number of neutrons, it will start. If you want to shut down, you just close down, so that number of neutrons are closed. It will stop. Right? Okay, this is the how multiplication factor, like K factor, how it is controlled. I think we are done. I wanted to speak something on this is how actually I don't know video is done or not. Video it will not run. It will not leave because we have to conversion. So can you close down? Please help me out, someone. Please close. Yeah, I'm sorry, I'm not able to show something. Can you close down this? How nuclear reactors work, you will understand.
This video is focused on the details of how pressurized water nuclear reactor works. Nuclear power plants are advanced versions of conventional power plants. When a furnace nuclear power plant is replaced by a nuclear reactor, it becomes a nuclear power plant. Since a nuclear reactor is a controlled nuclear heat generator, aka a nuclear bomb, it requires
Okay. So whatever you see, if you see this video, you will understand how nuclear reactors or electricity is generated. See, for electricity generation, you require electricity. Your electricity is generated by your generators, not by coal or not by coal, not by petrol, not by coal. You need to run your turbine actually. So for turbine run, what you have to do, you have to make it either you have to engine or something, or you have to do steam. For making steam actually coal and other things are. Okay, if you have hydropower, you can directly put the water and you can run a turbine. So in nuclear reaction, suppose there is a core. This is the core, where heat is generated. Now heat is generated, if you pass water, it will create some kind of steam. And this steam is actually passed, it's so simple. How it is controlled? There are three things. Pressure, water and steam. You may be telling the water is actually pressurized. Why it is so? Pressurizing the water. See, someone knows like a Carnot cycle or something? What is this? Carnot energy efficiency? Okay, the cycle. What is called as Carnot efficiency, energy efficiency? T2 minus T1 upon T2. See, if your engine heat and your sink is at high temperature, your energy efficiency conversion will happen. So for example, okay, I'll tell you later. See what happens? Unless actually to pressurize water, we start boiling at 100. And we don't want to make water boil at 100. We want to make it at 200 or 300. So ultimately, what is the object of the way is to pressurize. You pressurize it, it will not happen. So, and if you are pressurizing, that's why you are able to reach at more than 200 degrees. And your sink is at water, the sink is at 100 degrees. So if your engine is at 300 degrees centigrade and sink is at 100 degrees centigrade, you convert the conversion of energy factor, it will come around something like 30 or 40%. But if you see 100 degrees and your sink is actually suppose normal 25 degrees centigrade, it will come out 5%. You can convert yourself. That is the why and it is always operated at high temperature. So get maximum energy conversion factor. 100% is not possible to come, right? So that is how actually engines are modified. So what is actually done? Now I will see. You have a rod, right? Free rod. You have nuclear reaction test, and this is the control rod. Control rod is nothing but something like neutron absorber. Apne samajh lijiye like it is a sponge which absorbs neutron. So obviously, if we put down the rod, all neutron will be absorbed, no neutron. You want to increase the reaction, you can put down the rod. So pull up the rod. This is how actually nuclear reactors have control energy, and the heat will be there. And heat will be converted to something like water steam, which is nothing but connected to the turbine and your electricity. This is so simple. I think we will stop here. We'll have more on post because I feel you are more actually. You are not able to interact more. Either see, either you are understanding everything or you are not understanding everything, or we don't have an intellectual level.
Please ask. If you have any queries, you can
I
ask.
will stop here now. We'll have your doubt, your question answer, and then I will tell like some career guidance, career opportunities. Before I start career something, please ask some questions. कोई क्वेश्चन नहीं आपको मन में इतना बात चल रहा है इधर
प्रेशराइज वाटर और की आइडियल इक्वेशन देखने में प्रेशर जो है वो टेम्परेचर से डायरेक्टली प्रोपोर्शनल की रिलेशन में अगर हम किसी भी चीज़ का अगर प्रेशर इंक्रीज करते हैं उसका टेम्परेचर भी इंक्रीज करना चाहिए
that is the fact that is we want to हमको टेम्परेचर तो बढ़ाना ही है
सर ये जो प्रेशराइज्ड वाटर है तो इसका जो रीजन यही है कि जो जैसे हाई टेम्परेचर पे कोई चीज बॉइल कर रही है तो उतना हीट ना कर पाए तो प्रेशराइज्ड वाटर लेकर फिर उसको उसी चीज को कम जो है डिग्री को बॉइल कर रहे हैं
ऐसा में क्या कि सपोज जैसे फैक्टर क्वालिटी को बात C2 minus T1 upon T2 if you operate this T1 is nothing but your operating temperature T2C if you operate at higher temperature your efficiency conversion will be much more Carnot efficiency will go if you operate at higher temperature lower temperature में चल के आप energy conversion over 5 times you want more than 15 to 40%. So that is why it is operated at high temperature. Carnot cycle तो इंजन का standard formula है.
Yes.
और क्वेश्चन किसी
I have a question.
प्लीज बंद करो
हाँ बंद
जब मेरी स्टूडेंट पहले क्रिटिकल पॉइंट पढ़ाता थी कि कैसे करके तो पीएचडीआर का आरए क्रिटिकलिटी अटेन कर लिया उसकी तरफ तीन चीज है
नहीं उस पे सेम चीज देखिए मैं अभी आपको फिर सी इंडिया देयर टू टाइप्स ऑफ आप रिएक्टर जो ऑपरेट होते हैं वन इज कॉल्ड एज research reactor is only for different purpose because the reactors are the source of proton जो आप all medical application में और isotope यूज होते हैं ना तो हमारा रिसर्च reactor है because वहाँ पे फ्लक्स बहुत ज़्यादा होता है and कंट्रोल करना so we irradiate something and then वो सेपरेट करके प्यूरिफाई करके आपको देते हैं it is the research reactor that is different इंटरनेट तो उसका पावर कम होता है सब कुछ होता है बट एक होता है पावर reactor इलेक्ट्रिसिटी So in India, if you see, we have more than 25 reactors. They are called PHWR, pressurized heavy water reactors. Reason is, we are using natural uranium. Natural uranium is uranium 237 is only 235 is only 0.7%, right? So 0.7% if it is consumed, you have to remove it and then again you have to recycle. So the problem is what? How now you are getting natural uranium from the market? In India, we have UCIL. UCIL is Uranium Corporation India. They are producing uranium, but that is not sufficient for it. So एक दो लीटर पे ये मरता है. 90% हमारा uranium जो होता है वो import. So today suppose things are favorable. Like हमारा हॉर्मोन रोक दिया, ईरान ने हमारा तो असर नहीं हो गया. क्या करेंगे? तो इंडिया इज प्राउड टू से दैट हम लोग प्रिपेयर हैं सपोज इन फ्यूचर प्रोग्राम क्या फॉर एग्जांपल अभी तो हमारा नेचुरल यूरेनियम होता है इंपोर्ट तो दे आर यूजिंग पीएचडब्ल्यूआर ओके बट अगर कल नहीं कोई क्या करें कैन वी हैव टू डू द ऑन सो व्हाट वी आर डूइंग वी आर टेकिंग यूरेनियम एंड इन रिएक्टर वी आर प्रोड्यूसिंग प्लूटोनियम 239 बिकॉज़ मेजर इज 238 that is converted to 39. So Homi Baba ka that program, that 3-stage power program was the first one. First, second and third stage. In 50 we will be getting a third stage, 220. So first stage we have matured, like ingredients, all sorts of converters. That is called as PW transfer. But उसमें जो प्लूटोनियम निकलता है, उसको हम लोग second stage में as a neutron source and as a fissile content. Because we will be using thorium. So thorium, अगर देखा है ना, thorium उसमें blanket डाला जाएगा, so it will be producing more uranium 233 than it is cadmium with uranium 239. So basically, we will be producing more and more fuel rather than consuming. PFBR, P का मतलब होता है prototype, it is not a very big. इससे पहले जो हमारा था that is called as FBTR, fast breeder test reactor. We operated fast breeder test reactor because we were not producing electricity. So हमारा test reactor का सब physics और समझ लेंगे. That is mature now. Now we have prepared prototype, which is like a small commercial reactor that will produce electricity. Okay, and at the same time it will be producing more and more fuel. तो हमारे पास sufficient fuel हो जाएगा, then we can use thorium and uranium cycle itself. Self sustaining. So this is our future program. But second stage में तो we are जो है, we are producing more fuel rather than we are consuming. वहाँ से fuel produce हो रहा है thorium. अभी थर्ड स्टेज में हम क्या करेंगे? प्लूटोनियम यहाँ डाल रहे हैं, वो नहीं करना. सीधा हमारे पास uranium 233 हो जाएगा sufficient. Then we can mix uranium together. We can run reactor like this. हो गया? Any other question? Any other question, please?
इनको
आप अपने कैरियर के बारे में कुछ पूछ रहे हैं? आपको क्या
कैरियर
करना है?
कैरियर गाइडेंस एटॉमिक एनर्जी सेक्टर में
Please.
सर एक मतलब ये जो न्यूक्लियर रिएक्टर्स होते हैं उसमें मतलब यूजुअली मतलब जो बॉम्ब वो एक्चुअली क्यों बनाते हैं?
देखिए वो स्ट्रक्चर डिजाइन नथिंग है. वो स्ट्रक्चर डिजाइन है नथिंग है. अंदर जो होगा सब फोर थिंग्स But that is,
some other nuclear reactors में don't expect.
I'm telling you that that is the instructor design. Like our mechanical engineer का design करते हैं. See, whatever we are reading, वो तो simple है ना, यहाँ से लाओ यहाँ का आदमी चलाएगा. Actually, वो design करके that is design. So that part is different.
No talking.
See, कितने बच्चे इसमें एससी वाले हैं?
आप बताइए।
हाँ बताइए।
MSc।
हाँ वैसे बिल्कुल। अब बाकी सब बीएससी के हैं।
BSc 6।
सर एमएससी फिर इसके बाद स्कोप क्या है?
एमएससी के बाद आप लोगों का प्लान क्या है? आप लोग एमएससी में एडमिशन ले लिए। व्हाट इज योर प्लान? देखिए आप लोग अगर प्लानिंग नहीं करेंगे तो किस तरह? अरे देखिए
नहीं भाई आप क्या करते हैं? बताइए बेसिक का क्या प्लान है? पूछिए
अपॉर्चुनिटी है बहुत अपॉर्चुनिटी बहुत है व्हाट इज ट्रैकिंग इज एक्चुअली पावर वी डोंट नो दैट बहुत अपॉर्चुनिटी सपोज यू आर डूइंग मास्टर आपका बेसिक फंडामेंटल तो क्लियर हो जाता है पीएससी का then you can qualify for so many like exams जो है वो भी करते हैं but there are some areas जहाँ पे आपको ना बहुत बेनिफिट है फॉर एग्जांपल अभी फिर आपका इसरो एंड ये बीआरसी ये दो डिपार्टमेंट एक ऐसा है यू मे बी नोइंग कि इट इज नो रिजर्वेशन जीरो see our department BRC is the only department or and ISRO where there is no reservation all are equal no problem बच्चे समझ रहे तो आपको जो ना बहुत सारे लोग fear factor है कि वो बहुत सारे कोटा है ये है वो सब आपको अप्लाई करना अगर आप BRC में इसके लिए बहुत सिंपल तरीका है एवरी ईयर 1 जनवरी से और लास्ट का क्वेश्चन पर वो रीडियल पूरे कोर्स में साइंस एंड इंजीनियरिंग का एग्जाम तब मैं क्लियर कर रहा हूं अब लास्ट में क्लियर किया सॉरी इसका मैं लास्ट में शेयर भी करूंगा एनी पर्सन any student who are actually currently in second year or the final year because only criteria is they should be getting their degree in the month of May because May में हमारा interview है at the time of interview you should be prepared with your original market उसका एग्जाम का जो फॉर्म है एवरी वो निकलता कब है आपको द एंड ऑफ दिस दिसंबर और जनवरी एंड उसका लास्ट डेट होता है 31 जनवरी एवरी और एग्जाम होता है फर्स्ट संडे ऑफ मार्च फर्स्ट संडे लाइक नीट का दिस होता है इस तरह से तो आप अकेडमी प्रिपेयर करिए एंड उसके लिए क्या होता है इस टाइप के क्वेश्चन 100 क्वेश्चंस है आउट ऑफ 3 ऑफ 120 मिनट्स है 100 क्वेश्चंस एंड पॉजिटिव क्वेश्चन जो है आंसर ऑफ 4 मार्क्स और नेगेटिव मार्क्स and then you will be called for तो ये तो एक है
क्या कहना चाहते
अदर रूट इज
सर तो ये कैसे भी बात
because what happened
बाहर
now conducting examination by government it is actually very clear
वही तो बता रहे हैं बात सर कैसे बोलते
I will suggest
गुस्से नहीं बाबू
they should start gate जब तक कितने तक गेट किया एग्जाम कर दिया क्या पैसा तो कर रहा और
12 नहीं
बट बेटर राइट
12.30
बट क्वालिफाइड के ऊपर हो गया ना आपका
नो
नो
क्या क्या कितना है
12.
देखिए जो भी एमएससी की स्टूडेंट है unless and they qualify gate examiner you will not be like able to crack it it will be very difficult to get a government or any some standard so your first priority should be you should be qualified on it. It will help you not only in BRC BRC there are two methods either BRC के अंदर एग्जाम जाओ और by game, every year the percentile published होती है. अब percentile all will be confirmed. ठीक है. Sorry, आपको बोल तो नहीं हो रहा ना?
No, sir.
काम कर रहा है. तो even BSc जो student अगर उनको फ्यूचर में लाइक दे आर नॉट गोइंग फॉर एमबीए एंड ऑल दिस थिंग बात हम फील्ड करते हैं दिस विल स्टार्ट टू the only and only